All right, so then we talk about the functional unit of muscle. Now back on the page, end of page 45 on the 46. So certain muscle fibers are going to have more innervation to them. If it's just a muscle that's just for brute strength, either it's going to contract something like, say, for example, your thigh muscles and things like that, they're not going to need a whole lot of different innervation levels. Whereas if it's a more fine control muscle, like in your hand, things in your eyes, that have to have more fine control, those are going to have more nerves going to that muscle per square inch than other muscles are. So then the fibers are the motor muscle fibers for a motor unit are spread out throughout the muscle. So then that's going to contract the whole muscle. And then you talk about, so here's the functional unit where you're having, this muscle has more than one motor unit going to it. And then that goes out and divides, and eventually all the muscle fibers are going to be supplied by that motor unit. That's what's going to actually make the muscle contract. The nerve impulse goes to the muscle, and that causes the muscle to contract. All right, then we talk about muscle tone. Obviously, to maintain my standing posture like this, I have to contract certain muscles. Okay? A lot of times it's going to be things like the soleus, and there's a certain amount of tone that's maintained in muscles. And some people can have other types of conditions where they have too much muscle. Like if you have paralysis, there's two different types of paralysis. You can have upper motor neuron lesions and lower motor neuron lesions. Okay, you see people that have like cerebral palsy, that's upper motor neuron. So if the nerve if the process is dead starting from the beginning of the brain, then the second neuron that goes to the muscle, what that one does is it helps to inhibit, the upper motor neuron helps to inhibit the muscle. So there's no information going to the muscle to relax it, so you get tonic paralysis, stuff like this, right? But if the lower motor neuron, that's the one that actually makes the muscle contract. So if you have a lower motor neuron lesion, then you have like flaccid paralysis. That's going to be like quadriplegics, hemiplegics, like that. Their muscles are flaccid, they can't move them. Whereas cerebral palsy, if it's stopped from up above, then you have like spastic paralysis, things like this. So, and then there's different parts of the brain that help to maintain muscle tone. So that has to do with balance and proprioception and things like that. Because you have to have a certain amount of tone in the muscle to maintain posture. And it keeps them ready to move, ready for action. All right, now this is the open closed chain. This is going to be something that's, a lot of times it's talked about physical therapy, or you're talking about movement, you're talking about or you're talking about exercises, and you say, well, okay, you should be doing open chain exercises or closed chain exercises. Basically what this means is that you have, say, talking about the upper extremity, each joint together functions together, and it creates a whole chain of movement together, right? So, and then in the lower extremity. Like right now, moving my legs, this is a closed chain. Because when I move one thing, it affects the other joint because the distal part is in contact with something. So my lower extremity, the distal part of the extremity is in contact with the ground. So when I move like this, I'm moving the ankle, the foot, the knee, the hip, things like that. Where if I'm just doing an open chain like this, right on here, right, I'm just moving pretty much the knee joint by itself. It's not necessarily directly affecting all the other joints. So open chain is where the distal part of the extremity is not in contact with a solid surface. And then closed chain is what it is. Okay, so it's just a general concept to understand. So when you hear the word, we talk about open chain movements and closed chain movements, that's just what that is. I don't think that's in the book, and it may not necessarily be on quizzes and tests for this class, but it's just information that you'll hear about, especially if you're getting into a lot of exercise physiology and things like that. So there's just more information on that in the notes. But basically the idea is that Open chain is when the distal part is not braced on something, and you're moving more likely one joint at a time, whereas closed chain is involving multiple joints. And then, of course, we've all heard about aerobic exercise, right? Aerobic is where you're using oxygen at the same time that you're moving the muscles. So doing aerobic exercises, that's what's going to help develop your cardiovascular system and your respiratory, because your body's going to be needing to bring in oxygen in and out. And so that's going to have certain muscles are going to function better in that. They're going to have a lot more mitochondria and then have a lot of myoglobin. So that's the idea between the, like I said, white meat and dark meat. And then when you have resistance exercise, that's usually going to be anaerobic. That's like where you're pumping the weights, right? It's a short duration type of thing. You know, you're lifting a weight like that. It's not like you're constantly using the muscle like you're jogging or swimming. It can be just a short burst where you don't necessarily need a lot of oxygen, because whatever energy is in the muscle, it's just used right away for that one sudden short burst of energy. Okay, and then those are the types of things that if somebody's lifting weights and doing anaerobic exercise, that's more to build muscle. You're going to get hypertrophy of muscle. Whereas if you do aerobic types of exercises like swimming or jogging, you're going to have a different type of a body build. You know, a swimmer is going to look different than the governor, right? And then they're going to have glycogen stored in the muscle, because they're going to do a short burst of exercise, so the energy is going to be stored in the muscle. It's just going to use what's right there. It's not going to need to bring in more energy. So basically, it's like when we were talking about with that Wolff's law for bone, similar type of thing with muscle. If your muscles are forced to work, they're going to have to get themselves in shape. You're going to get increased muscle, build things up. Right? So then this other part here is what we talked about last week. We were talking about muscle naming, right? The muscle first name. So just to review, slides here. Again, muscles are going to be named based on the location where you find the muscle. So this is the notes on page 48. And then the shape of the muscle, like the deltoid, the triangle-shaped muscle. And then if there's more than muscle in a similar area, then you can have subdivisions based on size. You have gluteus, medius, minimus, maximus, things like that. So the size of the muscle in relation to another. And then muscles are going to be named on their direction of the fibers. Okay, so if it's a straight muscle, like we talked about a few different straight muscles. We talked about rectus abdominis, rectus femoris, things like that. And then if a muscle has more than one origin, you can have, like the biceps muscle has 2 heads, triceps has 3, quadriceps has 4. And then other times muscles are going to be named by the location of the muscle or their attachment. Like the sternocleidomastoid, that's basically named by the places that it attaches to. And then also muscles can be indicated about what their name of the motion that they produce, like flexor this, extensor that. And then sometimes they'll be based on their position. So sometimes one part of the muscle will change based on its size compared to another, and then it'll change on its location compared to another one. Now, medial, lateral. It's like extensor radialis longus. Okay? It's named by its action, so it's an extensor. It's named by the location where it goes to the radius. And then also rotation, call for.
My question is, when you're saying bicep, you're saying the muscle has 2 heads. What is it?
Oh, okay, I didn't understand the question. Yeah. Why does muscle have more than one head? Yeah, that's muscle attachments.
Oh, okay.
So then we have a long head. On this end, there's only one insertion. There's a single tendon right here, but as you trace the muscle up, there's 2 heads. So that's why it's called biceps. So it has a long head and a short head. And then triceps has one insertion, but 3 origins. And a lot of times, in specific ones like the triceps and the biceps, one part of the muscle is going to go across 2 joints, and another part will go across 1 joint.